Good morning, students. In our last class, we complete the question number 5. So I hope all of you understood this question number 5. So after that, the next question is question number 6. And if you see the question is here given in figure 6.21, that means the figure is this one. A, B, C are points on OP, OQ and OR respectively. So that means OP. So here you see OP this one, and here one point is A, as well as in OQ B point is another one, as well as here in OR the third point is C. These three are mentioned here respectively, such that here another two conditions are given: AB parallel to PQ. So in this case you see here this AB parallel to PQ given, as well as AC parallel to PR. So that means here this AC parallel to PR, this one is also given. Is it clear? So after getting these two, now we need to prove here BC is parallel to QR. So where is BC? BC is this one, and we need to prove this one is parallel with QR. We need to prove. So now first of all, what you have to do, according to our given condition, AB parallel to PQ and AC parallel to PR, with the help of these two, we have to prove this one. So when AB parallel to PQ, if we check out in this diagram, so here you see AB is parallel to PQ, this one is. So if we consider the triangle POQ, then in this triangle this AB is parallel to PQ we get. So easily we can apply here the Thales theorem. Only for that reason we have to consider this triangle POQ. Second time, if you see POR, if we consider this triangle, then AC parallel to PR given to us. You see this one is AC parallel to PR given to us. So in this case again we can apply here the Thales theorem. So with the help of these two equations, we have to find out the third one, and finally we need to prove BC parallel to QR. We need to prove here. Is it clear? So in this way we have to proceed this one. So at first, whatever given, so from this given condition we have to write here. Clear? So that's why in this case the first triangle, which triangle we have to consider? We have to consider the triangle POQ, because AB parallel to PQ given to us. So that's why in this case, if you write in triangle this one, we write POQ. POQ, and here we have to write this one is AB parallel to PQ, and in bracket we have to write this one is given to us. Is it clear? So if you see the diagram here, diagram separately, if we draw the diagram here, this one is P, this one is O, this one is Q, and at this place this one is A, and here it is B. According to our question, this AB is parallel to PQ given to us. So AB parallel to PQ, this one is given. So AB is here, PQ is here. So that means this one is the third side. So if two lines are parallel, then according to our Thales theorem, we know what is the statement. The other two sides are divided in the same ratio. That means same ratio means the opposite vertices of the third side is O. So that means we have to start from O. So that means other two sides are OP and OQ. So according to our Thales theorem, what you have to write? The other two sides are divided in the same ratio. So that means we have to write here OA by AP is equal with OB by BQ. Remember this one. This one is the third side. For this third side, opposite vertices is O here. So we start from O. OA, AP, OB, BQ. So if you write one time suppose OA AP, or second time if you write QB BO, then it is wrong. So always we have to start from where? The opposite vertices. From here we have to start for the both ratio. So that's why here we write OA AP OB BQ. So that's why directly we write here, therefore by Thales theorem. So we have to write this one is therefore by Thales theorem, or we can write according to the Thales theorem. So in this also we can write. So here we have to write OA by AP is equal with OB by BQ. So this one we write here OB by BQ. OA by AP is equal with OB by BQ. I hope all of you understood this one. Okay, now this one we put equation number 2. So this type of one, another parallel lines are given. AC parallel to PR. So that means AC is here, PR is here. So only for that reason we have to consider the triangle, which one? POR. So that's why second time you have to write in triangle POR. So if you consider this triangle here, so in this case we have to write AC parallel to PR. Clear? AC parallel to PR we have to consider. So in this case, if you separately draw the diagram here, so if you see this one is the diagram here, so P is here, O is here, and R is here, and this one is the parallel line, and which one we consider here? A, C. So in this case, these two are parallel. So again, if we apply the Thales theorem here, for the third side, the opposite vertices is A. According to our Thales theorem, what we write? The other two sides are divided in the same ratio. So that's why, therefore, that's why here we have to write, therefore by Thales theorem. So that's why you have to write, therefore by Thales theorem, we have to write the other two sides are in the same ratio. That means here we have to write what? You see, OA by AP. So in this case, we have to write OA by AP. So this one is OA by AP is equal with OC by CR. So that's why here we have to write this one is OA by AP is equal with OA by AP is equal with OC by CR. So that's why we have to write this one is OC by CR. And this one we put equation number 2. Is it clear? So now if you see in between 1 and 2, one similarity is here, the ratios are same. Here OA by AP is here, as well as here also OA by AP is here. So easily we can compare these two. So that's why here we have to write, therefore from 1 and 2. Therefore from 1 and 2, what we get now here? The left hand sides are equal, that means the right hand sides are also equal. So that's why here we have to write OB by BQ is equal with OC by CR. The ratios are same, we write here. Is it clear? Okay. Now after writing this one, you will see here OB by BQ equal to OC by CR. So if you see the ratios where we get this one, so in this case we get OB by BQ. OB by BQ. You see here OB by BQ is equal with OC by CR. So that means this one is OC by CR. If you draw the diagram separately now, this triangle OQR. So if you draw the diagram separately here, this one is O, this one is Q, and here it is R. And this line is what? B and C. Now in this case, the ratios are same we get. You see here, OB by BQ is equal to OC by CR. So according to our converse of Thales theorem, if the ratios are equal, then the lines are parallel. We know this one, isn't it? So that means if the ratios are equal, then the lines are parallel here. So that means this BC parallel to QR. So therefore, here you have to write, therefore by converse of Thales theorem. So here we have to write, therefore by converse of Thales theorem. What we can write here, since the ratios are same, isn't it? So that's why the lines are parallel. So that means here we have to write BC parallel to QR. What we need to prove? You see here, we need to prove BC parallel to QR. So I hope all of you understood this one, BC parallel to QR. Is it clear? So if I repeat this one, if you repeat this one more time, if you see, first of all here AB parallel to PQ is there. So that's why AB parallel to PQ. Only for that reason, first of all we have to consider the triangle POQ. So in this triangle separately here drawn, you see POQ. So in this case AB parallel to PQ given. So that's why if the lines are parallel, then what we get here, the other two sides are divided in the same ratio. So that's why the ratios are this. So the same thing we write for AC parallel to PR. So AC parallel to PR triangle is this one, isn't it? POR. In this case is AC and PR parallel we get. So again we apply the Thales theorem. So when we apply the Thales theorem, we put equation 1 and 2. And if you see the left hand side, OA by AP same. So that's why easily we can compare, and we get OB by BQ equal to OC by CR we get. So after getting the ratio, if we see the ratio here, if we check out the ratio here, then we get OB by BQ, OC by CR. So separately here drawn the diagram, and here OB by BQ, OC by CR. Same. So that's why if the ratios are same, then by the converse of Thales theorem, what we get? The lines are parallel. So that's why here we get BC parallel to QR, which one is our proved here. So I hope all of you understood this question number 6. So in our next class, we have to continue this exercise and we discuss the question number 7. Is it clear? Okay, thank you.